Hi there, this is the video for lesson 4.2 applications of sinusoidal functions. So we're looking at applying the derivative rules for sinusoidal functions in word problems. So here we have an AC/DC coupled circuit that produces a current described by this following function, where T is the time in seconds and I is the current in amps. Find the max and min. So here's our function. We find the derivative. The derivative of cos is negative sign, so negative sign. Okay, and then we set that equal to 0. Okay, setting it equal to 0, simplifying it gives us, dividing both sides by negative 60 gives us sine t. Okay, now remembering that that's the sine graph. Okay, so starting at 0, goes up, hits a max, comes down through the middle at pi, and comes back up at 2 pi. So when is this function equal to 0? When time is equal to 0, pi, or 2 pi. So those are our critical values. Okay, there are critical values, not our critical points yet, because we don't know if these critical values produced an asymptote or maxes and mins. Now obviously, this being a sinusoidal function, it will not be asymptotes, and these will probably be maxes or mins. Now, so we're going to test the first derivative, so sub them in between 0 and pi, so a number between 0 and 3.1415. I'm just going to use 1 into our first derivative. So our first derivative is negative 60 sine 1, giving me a negative number. So this is decreasing. Now choose a number between pi and 2 pi. So that's between 3.14 and 6.28. So let's try 4. That gives us a positive value. Now 2 pi is 6.28 because 2 times 3.1415 is 6.28, blah, blah, blah. What number is bigger than that? Let's just choose 10. That gives us a positive value. Okay, which means it is increasing. Okay. Oh, sorry, I chose a value that's a little too big. Here's why. Let me erase that. Because don't forget, these functions are periodic, right? So if they're periodic, that means that you got 0, pi, 2 pi. These are not the only answers, are they? These are answers between 0 and 2 pi, because where else does it hit 0? Well, it's going to continue. Okay, so there'll be another critical value here, and so forth. They repeat, right? So the next value we're going to have here is actually got pi, 2 pi, and then 3 pi. Okay, which means that 3 pi is going to equal to 0 again. So I need to choose a value that's between 2 pi and 3 pi. Okay, so 2 pi is about 6.28. 3 pi, so that's 3 times 3.1415. So it's going to be a number slightly above 9. Okay, so I'm going to choose a number between 6.28 and 9. So let's say 7, okay, which gives me a negative value, which makes sense because then I know it's decreasing. So which means that at pi we have a local minimum, and at 2 pi we have a local maximum. Okay, so find the maximum, minimum, and maximum currents and the time in which they occur. So they occur at pi and 2 pi. Okay, so therefore minimum at t equals to pi. I don't know the y value yet, but I'm going to solve that in a second. And maximum at 2 pi. And again, I don't know what the y value is yet. I'm going to solve that in a second. And how do I solve that? Just by plugging it back into the original. Okay, so I'm going to have not the derivative, but the original. Oops. So the original, which is right here. So 60 cos, instead of x, we're going to have pi, which gives me negative 35 amps. Yes, so negative 35 amps. And pi seconds, so that means t equals to 3.14, let's say 3.14 seconds. Okay, and then maximum at 2 pi, so 85. Okay, so there's a maximum at t equals to 6.28 seconds at 85 amps. Okay, well, let's check this. So if I were to graph this on Desmos, which is right here, 60 cos x, okay, let's see, do I indeed have a minimum of pi negative 35? Pi negative 35 right there. And a maximum at 2 pi 85? Maximum at 2 pi 85. Okay? But of course you can see these are not the only answers. These are the only answers between 0 and 2 pi. Okay? So technically there are more answers. Now how would I show that? Well, there is actually a minimum at, it's not just at pi. It's at pi, and then at 3 pi, and then at 5 pi. So really minimums occur at t equals to pi plus, how do you go from pi to 3 pi? You're adding 2 pi, right? So pi plus 2 pi, k, where k is an integer. Okay, so why does that make sense? Well, if k was 1, right? So 2 pi plus 2 pi is 3 pi, which means at 3 pi another minimum occurs, which is true. So this covers every single one of these minimums forever. Okay, like for example, if I choose k to be negative 2, let's say, okay, if k was negative 2, then pi subtract 4 pi is negative 3 pi. That means there's a minimum at negative 3 pi. There sure is. Negative 3 pi. Okay. And then same goes for max. So max occurs at t equals to 2 pi. Okay, and again, same kind of idea, 2, 4, and the next one 6, 0, negative 2, and negative 4. Okay, so it's plus 2 pi k, where again, k is any integer. Okay. Now, if you think back to advanced functions for a second, it says for the given current, determine the period, frequency, and amplitude. Well, we kind of already did that, but I'm just going to rewrite it down here. I'm going to rewrite this function using y and x's to make it more familiar. So y equals to 60 cos x plus 25. Well, we have to determine the period. So the period is 2 pi divided by k. What's our k value? Again, this is from advanced functions. Okay. K is equal to 1, which means my period is just 2 pi divided by 1, which is 2 pi, which we already established because we realized that our minimums repeat every 2 pi, and our maximums also repeat every 2 pi. Okay? And then our frequency, well, how often it happens, okay? And then our amplitude is 60. Then we make this red. Our amplitude is 60. What's the amplitude again? It's the distance from the middle to either the max or the min. Okay, so if our amplitude is 60, that means that, so if you look at this function, our middle line is 25 because this value right here, the plus 25, tells us our middle line. So y equals to 25. Okay, so 60 is the distance from 25 to the max. So 25 to 85 has a difference of 60. Okay, or all the way to the minimum. So again, from 25 to negative 35 is also a difference of 60, and that's what the amplitude shows us. Okay. All right. Sketch the function over 2 cycles. No, this is a review of advanced functions. So to sketch this, we've got 25 is our center line. So there's no scale given here. Okay, so I'm going to, and I know I need to go up to 85. So let's see, 25, 50, 75. We can do 25, or 20, 40, 60, 80. You know what, I'm going to go by 20s instead. Okay, so 20, 40, 60, 80, negative 20, negative 40. Okay. So now I know that this is my middle line, 25. Okay, so 25 be about right there-ish, just slightly above the 20. Okay, I'm just gonna see if I can zoom in a bit. I'm gonna rewrite the function here. Y equals to 60 cos x plus 25. So 25 is right in the middle. That's our center line. It's not a perfect line, but you get the idea. Okay. Now, how you sketch this is up to you. Okay. But what I like to do is draw two sketches, one with the phase shift and one without, so you can see the physical phase shift. But in this case, there is no phase shift, right? So this should be pretty simple to sketch because 25 is our middle line. So where's our max? Our max is from the middle plus 60. Okay, so 25 plus 60 is 85. Okay, so 85 would be about right here. 80 just above it. Okay, so I'm going to draw a dotted line here. I wish there was a line drawing tool on this thing. It goes right across. Okay, and then 25 minus 60, so 25 plus 60 is our max. 25 minus 60 is negative 35. So negative 35 would be somewhere here. Guess in hindsight I should have gone up by 25s, but it's fine. We're just drawing a sketch. Okay, so this is 25 minus 60, which is negative 35, 85. Max, min. Okay, now that we have that, all we need to know is how big the period is. So the period is 2 pi over k, which is period is 2 pi over 1, which is just 2 pi. Okay. So now cos graph, it always starts at the top, starts at the max, unless it's a negative cos graph, in which case you start at the bottom. Okay. And I know that 2 pi is a full cycle, which means if I start there, then after 2 pi, where's 2 pi? Right here. I should end up where I started. Okay. Now we just start halving it. Okay. So because I know between the two maxes would be where the minimum is. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 blocks between the two, which means at 4, I'm going to hit a minimum. Okay. Now when do I hit the center line? Well, I hit the center line on the green line, halfway between the max and the min. There are 1, 2, 3, 4 boxes between max and min. So that means at 2 boxes, I'll hit the middle line. So again, at 2 boxes, I hit the middle line on the other side. There's my sketch, I'm done. And this will match the Desmos graph perfectly. Okay. I know it says draw 2 cycles. You just have to take those points and repeat them. Yeah. So what that means is, I know a cycle is 2 pi, which means it's 8 blocks. So it's going to start here. Okay. Now take that dot and just add 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. Take the minimum at 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. Oops. 1, 2, 3, 4, 5, 6, 7, 8. And so forth. And you just continue and draw the second cycle. Okay. All right. A lot of these other questions are pretty much the same thing. Okay. All you have to do is find the derivative first in order to apply it. Some of them are wordier than others, but it's just about finding the derivative. So what I'm going to do is obviously post the full solutions. If you need help with the other 2 examples, send me an email and I'll be more than happy to help you. But I don't think I need to include these in the video, only because they are the exact same thing as example 1. Okay, take care.